And now from here, we'll go to generation. Generation task is exactly the same. There is nothing different that we are discussing here. There are a couple of other parts that we will talk about, but the initial part of generation is exactly the same as what we covered before. So whatever we discussed in classification, generation is exactly the same. The only difference is you can just kind of ignore this part for a minute. I will talk about this part later on. The generation is exactly the same. You can see there's no difference, absolutely no difference. And here, when we cover generation task, we will take the example of a meeting summarizer use case. Okay, so what is the use case that we will take up right now? We will take the use case of a meeting summarizer kind of an application. This is what we will do for the generation task. Okay, so this is the plan ahead. So we'll start off with generation, discuss very briefly 5 minutes in terms of how the generation tasks workflow looks like. Very similar, few short examples, gold examples, uh, design the prompt, evaluate the prompt, but the metrics will be a little different. Right? Just like in classification, we talked about accuracy, F1 scores, confusion metrics. So here it won't be the same. Here it will be, the metrics will be slightly different. So we'll do that. I'll show you a case study. We'll solve a case study, and that's the general plan for the next 1 hour. So now we are looking at the workflow of a summarization or generation task. And when I discuss the generation task use case, we are seeing this in the context of a meeting summarization use case. That is the use case I'm taking up right now. Something very similar to what we saw yesterday. If you remember yesterday, we did a very similar kind of a meeting summarization task yesterday, where there was a transcript of a meeting. And based on the transcript of a meeting, you have to generate the summary of a meeting. That is what we are trying to do. Okay, so based on the meeting transcript text, you have to generate a meeting transcript summary. Summary of the meeting is what you have to create. And we want to generate an application for it. That's the idea. Yesterday, what we did, we just tried a random prompt. There was no evaluation we saw. We just wrote a system message and we gave a user input and we saw some response. But it was not a complete end-to-end workflow. What we are seeing here is the same application, but we are packaging this into a more end-to-end workflow where we take the data, we split the data into few short examples, gold examples. Using the few short examples, we design the entire prompt, and then using the transcript in the gold examples, we generate the response summary, and then we test that response against the actual summary. Okay, so this is something very similar to what we discussed in classification, just that we're extending this to generation task. Okay, now everything is the same. The only thing that will change is the method of comparison. So if you remember in classification, we use something called accuracy. We looked at something called the confusion matrix. We looked at something called the classification report. So we evaluated the model performance using the confusion matrix and the classification report, because that is giving us the class level performance. So using the classification report, we can understand how is the model performing for each and every individual class. So class 0, how is the model performing? Class 1, how is the model performing? Class 2, how is the model performing? So we are able to understand the quality of the model for each and every individual task. And that's the way how we understood the idea of the how to evaluate classification models. Now, when we talk about generation models, summarization models, generation tasks particularly, we cannot compare it like we did for classification. Why? Because the generated text, in this case, the generated summary, the predicted summary, will never match the actual summary. Please keep this at the back of your mind. So the predicted summary, whatever the summary the LLM is predicting based on the transcript, that will never match the actual summary. The predicted summary will never match the actual summary. Okay, so whatever summary the LLM is predicting will never match the actual summary. That's the way to look at it. And that is why we do not use accuracy as a metric. We do not inherently use accuracy as a metric. Because even if you use accuracy as a metric, what will happen? The accuracy will always come out to be equal to 0, or it will be very less. Classification was different. If you go back to classification, the last exercise we did, let's say the model predicted positive, actually also is positive. Like, you can't generate a different answer, right? In the system message, you are clearly saying that based on the sentiment, please output the response either as positive or negative. You are very clearly defining the bounds of the system. The response could not have been anything other than positive or negative. Even if you go back to the patent classification exercise we did, we were very clearly listing out that based on the patent text, we want the outputs to be only out of the 8 defined categories. We very clearly defined what those categories were. So whatever response the LLM will give will be only out of those 8 categories. That is why we call it classification, right? Let's say in your organization, you're trying to do some kind of document categorization. It'll only be out of those 8 categories. The LLM will not generate something randomly on its own. But generation tasks are different. Generation tasks are where the output can be completely different. It's a much more open-ended problem, right? We were discussing this yesterday, right? We were saying, okay, typically for these kinds of things, the temperature setting should be much higher because the output can be something very different. Like even in this class, if I ask each one of you to generate a summary of the meeting, every single person will write the summary in a different way. Each person will write the summary in a different way. No two-person summary will be exactly the same. So that is why we do not use accuracy. We don't do a text by text, character by character comparison, but rather we will use a more of a semantic comparison. And here we will use something called a BERTScore. Now I will not be getting into the technical details of BERTScore. BERTScore is again a transformer based concept. So we use word embeddings and sentence embeddings to compare the meaning, the inherent meaning behind what those summaries are relating to. But at a very high level, we are doing a semantic comparison. We are not doing an exact word by word or character by character comparison, but we are doing a semantic comparison. Semantic comparison basically means you are looking at what is the meaning of this summary. You're looking at the predicted summary. You're trying to focus on what is the meaning of this summary. What is the actual meaning that is present in this summary, and you're comparing that with the actual summary meaning. So this is the comparison that you're making using the BERTScore. Okay, so this is the only difference that we will see, and it is based on something called a word embedding. So anybody who is coming from again a traditional NLP kind of a background, and that's why I say there's a huge relationship of Gen AI with other preceding topics. Okay, if you don't know that, that's okay. At a high level, you can understand this some kind of a accuracy metric. But people coming from a traditional deep learning NLP background, if you have heard of word to vec, word embedding, glove, those kinds of models. Okay, skip gram architectures. If you know word embeddings, what they are. So this is exactly that. So you're taking the summary and you're somehow representing that summary in a sequence of in a vectorized form, and you're comparing that vector of numbers with the actual vector of numbers, right? So at a high level I can explain the concept. Don't need to get too much into the detail of it. At a high level I can explain the concept. Okay, so this is approach number one, where we use something called the BERTScore. And BERTScore is used in scenarios where you know the actual summary. The actual summaries are known to you. So this will work in a scenario where the gold examples are known to you. If you know the gold examples, this strategy will work very well. That is if the gold examples are known to you. But in a lot of real world scenario, if you think about it, in many real world scenario, the gold example will not be known to you, right? Classification tasks are a different ball game. You are trying to take something and you're trying to classify out of those 4 or 5 distinct categories. So classification tasks are different. Okay, so you have a series of 4 or 5 tasks, and you're trying to classify the text into one of those defined categories. That is what we are trying to do in classification. Okay, so there you can very clearly have a ground truth. We can have some explicit gold examples. We can have a ground truth or a test data. But in generation tasks, oftentimes in real scenarios, you will not have a ground truth data. You will not have a gold example, because think about it. If I give you a transcript of a meeting, what is the ground truth for what the summary should look like? Think about it. Do we even have a ground truth? Is there anything called a ground truth there? Is there anything called what is expected? No, right? It's very open-ended. Anybody can write a summary of a meeting, and all the summaries will be reasonably similar. But we don't really have a ground truth, right? We cannot really say that, hey, this is the benchmark summary. Okay, if I ask you to write a marketing advertisement, a generator, if you think of any kind of generation task, let's say generating a post, a social media post for some marketing campaign or for some new product launch that has happened. What is the ground truth for that? If I have 100 people in this audience write 100 different social media posts, all of them will be equally okay, right? It's very hard to write. And who will judge? Who will say this is right and this is not right? There is nothing called ground truth, right? It's very hard to define ground truths for generation tasks. Most of the time, you will not have a ground truth. But classification task is fixed, right? If I do sentiment analysis, if I give you a particular review, you will have a ground truth that, okay, this is positive, this is negative. There is no debate about that. If I say the food was bad, I hated the food in the restaurant, everybody will agree that that's a negative sentiment. There is no doubt on that. That is how I want my system to behave. So ground truth is defined. If you look at the patent or the document categorization use case that we talked about, given the text of the document, it is a ground truth. We all agree that that is a fixed constructions category. We all agree it's a physics category because that is how I want my documents to get grouped in the future. So there is no doubt about that. Even if I have 100 people, 100 experts label that data, all 100 of those experts will say, yes, it is physics, yes, it is fixed construction. There is no debate about that. It's not an open-ended answer. It's a very close-ended answer. But in generation tasks, no two people will agree on the same summary, right? So how will you have a ground truth? Think about it. So if you have a ground truth, in rare cases, you will use a BERTScore. We use an embedding model to look at the meaning that is embedded in those sentences, and we compare them semantically. We do a kind of a semantic comparison. We don't compare them word by word, but we do a semantic comparison. We look at the meaning of summary one, predicted summary. We look at the meaning of the actual summary, and that is how the comparison is done. It is usually on a scale of 0 to 1. We will see the demo shortly. It is usually on a scale of 0 to 1. The higher the score, the better the model. And all it does at a very high level, all it does behind the scenes is, if I have to kind of compress this discussion at a very high level, all it does is it simply represents this as a vector of numbers. So you have something called a predicted summary. We represent the predicted summary as a vector of two numbers. Let's say 0.1, 0.23. That's your predicted summary. And this is the actual summary. And you represent the actual summary as a vector of two numbers, which is, let's say, 0.11, 0.22. See what we do. So the embedding model, what it does is it takes a text summary. Let's say the summary is like, okay, it's a big 100-word summary. So in a way, intuitively, what it does is it takes that text and it converts that to a vector, a numeric representation. And the actual summary also, it converts it to a numeric representation. And then what we do is we do a comparison. We use different types of distance formulas to compare. You can look at something like a Euclidean distance. You can look at something like a cosine distance. Okay, so you can compare 0.1, 0.23 with 0.11, 0.22. I think they're very close. They're very similar. So then you can say, yes, the BERT score is very high because these two documents are very similar. So we can confidently say the predicted summary is very similar to the actual summary, the ground truth summary. So the LLM model is working as expected. Okay, so this is a very high level idea as to how we use BERTScore. Now, if we don't have the ground truth summary, what happens then? Then we use something called LLM-as-a-Judge. This is approach number 2. So let me quickly go and remove this part. So if we do not have the predicted summary, what we do there, this part will go away now. This is oftentimes going to be the case. You will not have a ground truth summary. If this is not there, then what do we do? The same approach. You define a system message, you take the few short exemplars, right? Again, this is optional. Sometimes even the few short examples are not given. That is also optional, by the way. Whatever, you design the prompt, and once you have the gold example, you take each and every text from the gold examples section. In this case, the transcripts you take, the X you take, and based on that, you pass it to the language model to get a summary or the transcript of the summary of the meeting. And then you don't have a actual to compare. So you give it to one more LLM, and this is what we use as LLM-as-a-Judge. Okay, very popular way of evaluating language models. So we use another language model at the very end to evaluate the performance of the first language model. The first language model is the one that is responsible for generating the summary or doing the generation task, whatever. It could be a summary, it could be creating a post, creating an email, creating an article, whatever. The first LLM is responsible for performing the generation task. In this case, create the meeting summary. Based on the gold example, what is the predicted summary? Generate that piece. And then you take those generated summaries and you feed it to another large language model. This is usually a more powerful model. You can take a higher variant model in this case. You feed it to one more language model, and that language model acts as a judge. And you can design that language model again the same way. You can say, okay, there will be a system message, there will be a user message, right? You can design the language model the same way. and you can ask that judge model to rate the performance. How did the original LLM perform? You can ask the judge model to rate how the original LLM performed. Okay, so this is the way how you evaluate language models, especially for generation task in cases where the actuals are not known. Okay, so this is the workflow. The code is very simple. Now we'll see a small code implementation, how it is really done. Okay, so we'll see this in action now. All right, so I've already uploaded a folder called generation tasks here. And what I'll do is I'll take you through the first demo of how the generation task is done. Okay, and it will be following the exact same workflow that we covered here. Let us see. Let us see a very simple example of how a generation task is performed. And I will run the code also for you in the background. Very similar, you don't have to do it. So first thing, you will have to install the BERTScore, because BERTScore is a different package. It's a different library that needs to be installed. So if you're running the code, you need to install the BERTScore. And these are some evaluation metrics that you need to install also. And then you will go and do the same stuff. This is the same stuff. Remember, this is a different Jupyter notebook, but your API keys, what you did yesterday, is already saved. So nothing to change here. So I will just read the API key, get the API key from my secrets, which is the environment variable in Colab. So save it in this variable. My endpoint URL is the same. The version is the same. The deployment name is the same. Nothing to change, but you need to change it as per your deployment names and all that. Okay, just make sure you do that. And now let us come to the actual problem. Okay, so this is the judge use case, by the way. This is what we will demonstrate here. So remember, the first LLM is responsible for creating the summary. This is exactly what we will see. So we also have a very similar summarization use case here. So we take the input text, and the first language model will generate the summary. And the second language model, the judge model, will take that predicted summary and it will give a quality score. So to the second judge model, what do you give? You give the original input text, you give the predicted summary, and you ask it to rate it. You ask it to rate it, okay, based on this input text, whatever summary was generated, how did it perform? So one very important thing is, don't use the same model. If LLM1 and LLM2 should be different, LLM2 should be a different model. If you use the same model, then obviously the score will always be high. But you use a different model, it's like a judge, it's like another person. So you go to another person, a judge, and say that, hey, this was the text and this is what the first model predicted. So tell me how good the prediction was based on this text. Okay, so that's the way to look at it. All right, so now moving on, let us just see the use case. So we can, again, the same idea. The idea is the same. We are just assembling the data. So this is what we have. We've got lots of dialogues and summaries right now. So we've got lots and lots of example dialogues. I think the initial uh, installation is still happening. You can see. Yeah, this takes a little time actually. So you can see it's a big install that's happening. So okay, now it's successful. All right, good. Evaluate will be faster. Okay, okay, perfect. And now we will load the data. This should be fairly fast. Okay, and you can see this is my example data. We have the dialogue and the summary. So we have the dialogue and the summary. The dialogue summary, dialogue summary, dialogue summary. So this is my data. So as I said here, the actual summaries are given, but in a lot of real world applications, the actual summaries may not be given. That may not be always the case. So here the actuals are given to us. Okay. So rest of the part is very similar. You can see the system message, very, very basic system message, summarize the dialogue mentioned in the user input. Be specific and concise in your summary. You can make it more detailed if you want. You can add some more details, what kind of things you want to be in the summary. You can make it more detailed if you want. And this is a few shot prompt. So we are taking again a sample of, this will be a bigger, a slightly bigger, few shot prompt, because the summaries are actually quite big. The initial content is quite big, and so that's why it's a little bigger, you can see. So yeah, so this is the 4 few shot examples we have: user, assistant, user, assistant, user, assistant, user, assistant. So these are the 4 few shot examples we have right now. Okay, and now you can you can evaluate the model. I'm not doing that because this might take a little time. So I'm not doing that, but so now what will happen is you will go and evaluate the model, and after you evaluate the model, it will go and you can calculate a BERT score. And if you see, this is the BERT score that we are actually computing. So we are getting a BERT score which is close to 90.66. Remember, here we already have the ground truth data. So because we have the ground truth data, we are generating the predictions and we are comparing with the ground truth. You don't have to do it manually. You don't have to do the BERT score computation manually. All that we do is we just go ahead and use the BERT score library. Okay, so we say BERT score compute. We give the predictions, we give the references, which is the actuals, and the BERT score will give me a number. And turns out here, 90.9 is a very high value. So the BERT score ranges from 0 to 1. Okay, 0 is very bad, 1 is very good. So if the value is close to 1, 0.9 is very close to 1, right? So if the value is very close to 1, that means the predicted summaries are very close to the actual summaries. Okay, the predicted summaries are very close to the actual summaries, and this is expected because if you think about it, the GPT-4 Omni, the GPT-4o model that we are using is a very powerful pre-trained model, and the zero-shot learning works very well. This is not a domain-specific thing; it's a very general summary that we are trying to create. And these kinds of language models are inherently very good in summarization. It is not something where I have to teach it or something. It's already very good at these tasks. So that's the reason why even in a very basic kind of prompt that we wrote, we're getting a very high accuracy overall. But in cases where the original actual results are not known, we will use LLM as a judge. So same thing, we get the predictions, remember, and now what we do is we define the rater model. Now it is just for the demo that I've taken the same model. Okay, because otherwise I have to create a separate deployment. So what you need to do ideally is you need to go and create a separate deployment. So go here, go to deployments, and you need to actually create a separate deployment. Okay, just like we have used GPT-4o, you need to create a separate deployment, and then you need to say the rater model is equal to that model. You'll say model name equal to whatever. Let's say this is GPT 4.1, you say, and then you say the rater model equal to GPT 4.1. So that's the ideal way to do it. But anyways, so you can define the rater model, and the rater model is a separate LLM. It will have its own system message, and see how we are defining the system message. Very detailed, right? We're explicitly stating that the judge will have to give a score of 1 to 5. Okay, you look at the task at hand and evaluate on a scale on a scale of 1 to 5, 1, 2, 3, 4, 5. 1 means very bad, 2, 5 means very good. So the metric is not followed at all, and 5 means the metric is followed completely. And what is the metric we are discussing? The metric is this: the summary should cover all aspects that are majorly being discussed in the dialogue. Now, it's a very basic metric I've given, but you can make it longer, you can make it bigger. It is just how you teach a judge. Imagine that, like a judge is coming for some kind of an audition or some kind of an evaluation, some contest is happening. So even the judges will have to be briefed, right? So you are the person who is briefing the judge. Judge is already a very powerful model, but the judge has to be briefed. What do I have to do, right? So the metric is where the judge is being briefed. Okay, this is what you need to do. And this is where the judge is getting a kind of a criteria what to follow. This is like a rubric. Like in exams, when you write, you have a very proper evaluation rubric. What is graded, how it is graded, 2 marks, how the 2 marks is assigned, like that. Okay, so this is like the complete rubric that is given to the judge. Okay, so now the system message is defined. What is the user message template for the judge? So what are the things the judge needs to evaluate, right? It needs the dialogue and the summary. This is the thing. So the dialogue is the original dialogue from the gold example, and the summary is the predicted summary. Whatever the previous LLM is predicting, that is what you need. Okay, so we have the whole thing, and now you can kind of check. So based on the dialogue, this is what the first language model predicted, and based on the prediction, this is what the judge model basically evaluated. And you can see right at the end, I can just show you one of those examples, rating 0. Ratings is the data frame, right? I'm saving this in the ratings data frame. And if you see rating 0, you can see that in this data frame, if I see, this is what the judges rated. Okay, the summary is followed mostly, so the rating is 4-star. You can see this is how it's appearing. So the entire judges evaluation is coming up right now. But oftentimes, we don't need so much of evaluation. I mean, so much explanation we don't need, right? Explanation is needed only when something goes wrong. When something doesn't go wrong, explanation is not needed. So what you want to do in that case is you want to go and maybe refine the system message further. You can say, okay, do not explain the reasoning behind the answer. Don't explain the reasoning behind the answer. Just output a numerical rating 1, 2, 3, 4, 5. Because you have to understand that ultimately we are probably trying to use these language models output and saving it in some other structured relational databases, just like what we did yesterday, information extraction. So maybe the judge model, the output of this model is used downstream in some other system. That's also very common, right? The output of the model is probably used downstream in some other system. In those kinds of cases, you want to get a numeric output rating and you want to use that output downstream in some other system. That's the way to look at it overall. Okay, so that's the rater user message. Again, you can see. And you can see here the ratings are coming as a number. Not all the things are properly followed. So we need to further fine tune the system message, but mostly this is how we want it. We want to see like this is the way that will help me evaluate, right? If I want to do a continuous, a production grade evaluation, what will happen? I can do a week on week, a day on, a daily evaluation. I can do a monthly evaluation, fortnightly evaluation, that how my language models are working in production. Okay, so this is not only during development time. This is the same way that you will evaluate your language models while they are running on production. So while my language models are working in production, while they're generating the outputs, you can evaluate those language models in production, how they are performing. So every 100 queries, you can sample 5% of the user queries. And for those 5% of queries, you can pass it through a judge model and let the judge evaluate how that model actually performed in production. And that is how we can get some kind of a performance report, some kind of performance metrics we will get in terms of how the LLMs are doing. Okay, if there is any decay in quality, then we can decide whether to fine tune them and things like that. Okay, so we can get a week on week performance report. Okay, week 1 performance was up this much percent. Week 2 the performance dropped 10%. Week 3 it further dropped 20%, and then we can start questioning. Okay, why is the performance dropping? Because the judge is rating it low. Every week we're seeing, okay, the ratings are going from 5 to 4 to 3 to 2, and that's a concern. So that's why the production evaluation part is also a very, very central role that these kinds of LLMs as judges will play. Okay. All right. So I hope everyone's getting a very good understanding of the workflow, how generation tasks are actually done.